Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the summative questions as part of the culminating task at the course's end of the year. From the trigonometry section, this is question 16, and yes, for clarification, this is question 16 from May 2013. So it's been updated for the new version of the summative package and not the older question that some of you had been looking at. So let's go ahead and look at this new question 16. A hot air balloon is climbing vertically in the air. At one moment in time, a photographer observes the balloon at an angle of elevation of 25 degrees. A few minutes later, the balloon has climbed further into the air and the angle of elevation is now 60 degrees. The direct distance between the balloon at its highest point and the photographer is 450 meters. How far did the balloon climb between the two moments of observation? So first of all, the blue sentence is blue for a reason. When the summative questions were handed out, this sentence was missing, which made this an impossible question. So hopefully you've all now received this sentence, and if not, well, there it is. Write it down, press pause, try the question now that you have all the information. But assuming that you've already received the information about 450 meters and you're looking for the solution, let's continue on, shall we? So first, I always need to draw a diagram to figure out what's happening in questions like this. So we have an observer here, and some distance over, there's a balloon in the air. Yay! And so the observer looks at the balloon, and there's a 25-degree angle of observation. So this is called an angle of elevation, because if you look straight across, here's my eyeball. Hold on. Ooh, there's my eye. If you look straight across, you're at zero elevation. But when you start to look up, you have an angle of observation. Similarly, if you were to look down, that would be an angle of depression. So we want angle of elevation like there is here. Now, what happens is the balloon then climbs higher into the air. Those look nothing like balloons. And then the observer again looks, and now there's a 60-degree angle of observation. So that's roughly, and what I'm looking for is I need to know this distance here, which is the vertical distance the balloon moved between the two observations. Oh, and my other piece of information is that the direct distance here is 450. Now that's a pretty terrible diagram because I must admit I'm not so great at drawing using this tablet. So, aha, that's a nice looking picture. So again, what do we know? This is 25 degrees. Here I'll call this B1, meaning balloon 1, and balloon 2, its second location. This is 60 degrees. This is 450 meters. There's the information I have. Now, this right angle exists because the balloon is directly above the ground, so we would measure a perfectly vertical, um, orthogonal to the ground measurement to represent the height. That's how we measure height. As you know, the shortest distance is always measured as a perpendicular. And again, what I'm looking for, and I'll highlight it in red, is I'm looking for this distance here. So let's call that D. I'm looking for that distance. So what do we have? Well, looking at just the diagram, there's three triangles. There's the big triangle, there's the bottom triangle, and then there's this upper triangle. So the big triangle's right angled. We like that. The little triangle's right angled. I also like that. And then the top triangle, no right angle. Ugh, don't like that as much. So I wonder what we can do. So let's have a look at the entire big triangle for a second. So if I look at the whole triangle, I know that this is 450, and I know that this is 60. Now, again, because of this right angle, that means I can solve for this distance and this distance. Now, do I want to? Well, certainly this distance here makes sense to solve for because that green line will probably help me figure out what to do with the red line, right? Because it's part of the same side of that big triangle. What about the blue line? Is this going to be useful for me to find? If I look over here, that blue line is part of the small triangle, and the small triangle also makes up part of this whole side of the triangle. So that makes sense to me. We're going to go ahead and we're going to use the big triangle So here is another diagram, and I'm going to now emphasize what we're looking at. So we're only going to look at the big triangle where we have 450, and we have an angle here of 60 degrees. And then if this is theta, this is the opposite side, this is the adjacent side, and obviously this is the hypotenuse. So to find the adjacent side, we'll use cosine. 60 degrees is adjacent over hypotenuse. So in my calculator, cosine 60, oh, I should know this. Yeah, I should know this for sure. Cosine 60 is 0.5 over 1 is adjacent over 450. Cross multiplication gives me an adjacent side of 225 meters. Now I'm going to use sine opposite hypotenuse. So sine 60 is opposite over hypotenuse. So ask my calculator. 0.8660 is opposite over 450. Cross multiply, and I discovered that the opposite side is, let's say, 390 meters. So let's say, so we have an adjacent of 225. So now what do we know? So I'm just going to keep adding to my lovely diagram. That's 450. This is 225, and this whole distance here is 390. Now, again, I'm looking for this distance here. So if I can find this distance, that'll be immensely helpful because I can just subtract the blue distance from 390 and I'll know the green distance. So again, think about what other information I know. This is 25 degrees. This little triangle down here is a lovely right-angled triangle. And in a right-angled triangle, I get to use trigonometry. So the fact that I found that this side length was 225 meters means I can now find this blue distance. So now if that's theta, hypotenuse, opposite, and adjacent, I have adjacent, I want opposite, so I'm going to use tan. Tan 25 is opposite over adjacent. So I'll ask my calculator for the value of tan 25, 0.4663 over 1, and then I can cross multiply and discover that the opposite side is 105 meters. So back to my diagram, this is 105 meters, which means the green part must be 390 minus 105, which is 285 meters. Therefore, the balloon rose 285 meters. So that was interesting. I thought I'd have to use sine law, and I didn't. All trigonometry. So I hope that was helpful. Good luck in math. I'll see you in school. Study hard.